So today we are going to discuss the DBMS concept, which means Database Management System. And this is the first class. So I will lay down the foundation for the database management system. And there are some important theoretical points that you should be knowing because there might be a good descriptive question based on that or a MCQ question. And for that, you need to have clarity on the small theoretical concepts of the database management system. I will also tell you what all things we will cover in the due course of database management system for the entire NABARD syllabus. And DBMS will be relatively easier topic as compared to programming concepts and data structures. It is kind of lighter and it is more interesting and enjoyable topic which you will be able to digest very easily. There will be some concepts which will be tricky when we will come to the transaction and concurrency part, but other than that there is nothing that has to be worried about. It is very good topic, and most of the students have this as the favorite subject also because of the easiness and the understandability and also the relatability of the chapter with the daily life. So now we'll start with the DBMS concepts. And before starting, we should know what is a DBMS. And to answer this DBMS thing, we should know some things which are acting in the background. Like we cannot say that database management system is a software which do this and that. This is all correct, but in order to understand what is a database management system, we have to understand some of the things which are working in the background of the database management system. For example, here first we will start with the database and database user, because database management system is a big thing which is actually dealing with database as well as a management system. So better to understand what is a database, what kind of database users we have, why we need a database, and then understand the management system, and then combinedly understand the database management system or the database system at once. So there are many things which are different, but people have the notion that they are all same. We will break those myths also today, and you will get more clarity over the topics. So first of all, we have to understand database management system from the perspective of some history. Like in our daily life, we use many database management system. Either we know it or we don't know it. Like if you go for online shopping, you add items to the cart. You go for hotel booking, you search for some data, and then the hotels are listed. So from where the hotel list is coming as per the filter sets by you, it is coming from a database. Like airline booking, supermarket shopping, whatever you are doing, it involves some kind of database. Whenever I'm writing DB, it means database. So it involves interaction with the database. Now, all these interactions with the database are usually called as traditional database applications. So definitely when there is a database, there will be some kind of methodology to manage that database. So if the database are like this: online shopping, hotel booking, airline booking, supermarket shopping, these are some of the things which are called as traditional database application. And why we take them as traditional database applications? Because these informations are mostly stored and accessed in the form of texts or numbers. So whatever you are having here, that is stored here in the only the text format or the number format. It doesn't involve much of the different types of data which is getting stored. So that's why they are called as traditional database application. All the database applications which are involving only text or numbers, they are called as traditional database application. Now over the period of time, we have seen many applications evolving, and we have seen the major chunk of the database management system which is required right now is in social media, websites, and the applications. Also in the banking sectors, security sectors, these things require new kind of applications which are not limited nowadays to just the traditional database application which was having text or number. Now these database requirements, what they have as a requirement, these particular applications require huge amount of data to be stored, and different kind of data needs to be stored, like tweets, posts, images, videos, these different GIFs, different kinds of videos, different kinds of images. So we have to like the dimension of the data has increased from two perspective. One is the perspective from the size, that size has been increased. The data is generated every second. And the second thing is that variety of the data has also increased. So to manage that, we have a concept called as big data. So we have big data storage systems to manage the social media applications. We have NoSQL system also to manage these social media applications or the huge applications which require both the dimension, size, as well as the variety. So this is the background of the database management system and how we had it in past, and still we are having traditional database management system, and we are moving towards the different complexity of the management system daily. Now, what all are the scenarios that are covered when we say about database management system? So basically, first is the multimedia database, means a database which is having different kinds of media, like images, videos, different kinds of types of media which can be stored. GIS is one of the kind of geographical, one second. Yeah, so then GIS is the things which is used for the weather forecasting things and the geographical related stuff. So there what you will be having different kinds of real-time data which needs to be stored and analyzed properly in order to make decisions on the weather forecasts and these things. So basically it is called as geographic information systems, meaning I will write the full form also here. One second. Yeah, this actually stands for geographical interface system, and this is used by most of the like in India it is used by IMD, Indian Meteorological Department, which is responsible for storing the weather data. It is also used by the people who are using it for satellite data, for weather data, to analyze the maps and different kinds of things. Now the third one is the data warehouse and online analytical processing systems. So OLAP stands for online analytical processing. Remember this full form also. One second. If there is issue with the pen, give me a second. Much better now. Yeah. So OLAP stands for online analytical processing. Give me a second. What is this? So yeah, geographical information system, not interface. Sorry, my bad. I wrote it wrong. It is information. Sorry, information. And this is online analytical processing system where you use to extract the data and analyze important business information and support the decision making over the data. So data warehouses and OLAPs are also the scenarios where we need the non-traditional database management system. Then you have real-time and active database technologies which are used to control the industrial and manufacturing processes, because the procedure how to evaluate those all machineries and many complex machineries are being stored and they are followed as per the procedures there. So this is also one of the applications where we need different kinds of data and real-time applications to handle real-time scenarios. Now, there are also search techniques like when you use World Wide Web or internet or whatever for the searching things, you will require different kinds of database string matching things, and then only you can have the correct result if done, like the matching if it is done in the proper manner. So these are some of the scenarios. After that, let's understand what is data and then what is database. So data is something which is called as the known facts that can be recorded and have implicit meaning. This is the complete definition when somebody asks you what is a data. Data is known facts, means the facts which are known and they can be recorded so that we can analyze over them, and they have implicit meaning also. They have some kinds of meaning to them. It doesn't mean that they should have information inside it, information is extracted from the data or collection of data, but the implicit meaning will be attached to the data which we are using. Then database, what exactly constitutes a database? So it represents more of the aspects of the real world. It can be abstract or real world concepts, but moreover related to what we are having in the real world. Here you will have logically coherent collection of data with inherent meaning. Means the data will be logically collected, logically linked, and now this linked data will make sense with the meaning. Now they are most of the time specific for the purpose, like if I have some airline database, so that database is basically meant for the airline, so that is a specific purpose database. They are also for intended group of the users, like for the students database, the intended group of users are students, the teacher and the administration involved. And also for some preconceived applications we have the databases. Now, what can be the restriction on the size and complexity of the database? There cannot be any. So you can have of any size and any complex system for the database. There is no restriction that which size and what kind of complexity up till which you can expand or scale the database. You can do it like for the anything. Now, this was about the introduction. Now we have to understand that when we have databases, how do we actually like define them? So basically we have databases and we can define them in two major categories. The very first category you can say belongs to which are manually maintained. Basically the databases which are manually maintained. It is not like data. So in database also they can be manually updated and they can be automated also. Like if I ask you to do a particular task with the help of some software, you can also do it. And if I employ a software to do the work on the other software, that is a different scene. So software for software, working for software is automation. In person working for the software is manual. So it is manually maintained. But at the end, you are going to have a database management system. For example, if I say the library system, still we need a librarian to operate on the library system, that which book has been taken, which book is not taken. So you can see that librarian is also using a kind of software to or file system to input the data, to have the data, copies of data will be maintained by the librarian, but it is done manually. It is triggered manually by the librarian. So this is one of the things in which the database can be manually maintained. And the other thing is that it can be maintained by a computerized application. It can be maintained by a computerized application or program. And this is what we are interested to read about. This is the area in which our entire interest is lying. This is what we are reading in database management system. This is what we are interested to read about. So now if I say what is a database management system, I will take a new slide and will write it there. So now I will write just the words so that you can add them all together. So now if I say what is a DBMS, after learning these many concepts, DBMS is a computerized system. This is first thing that you have to make in your definition, is that DBMS is a computerized system that enables the user to create and maintain a database. That enables to create or maintain a database. Today my writing is very bad. I don't know why my hand are sweating so much. So if you don't understand any single word, please let me know. Enable to create or maintain a database. Now here we can have general purpose software systems also and some specific things also. For example, the general purpose software system which facilitates, like in the similar manner, if you want to state it in a different language, basically DBMS is a computerized system that enables users to create and maintain a database. Or you can say general purpose software system. You can also say or general purpose software system. general purpose software system that enables or that facilitates to process, that helps you, that enables basically to do what? To do definition, like defining, to construct, to manipulate, and share of database to the user and the application, among the users and the applications. So basically, I will again put it all together from the slides which we just saw. So database management system, we have to first understand what is a database. We understood how it has evolved. Then we understood different scenarios which involve database of today's time. Then the data and the database, how they are related to each other and how they are different from each other. Then how we can have database. So we can have database in two ways: manually maintained and computerized. So whatever we are going to study in due course of the chapter of database management system, it is the computerized application, means a software maintaining the data. Now, if I have to give you a proper definition, it is a computerized system that enables you to create or maintain a database, or you can say it is a general purpose software system. What is database management system? It is a general purpose software system which enables you to define, construct, manipulate, and enables the sharing of the database among the users and the applications. So this is, if somebody asks you how to define a database management system, this is the slide for you. You have to answer in this manner. Now, whenever you say database management system is a general purpose software system which helps in defining, manipulating, constructing, sharing, these all things, then we have to understand these steps which I say. What I mean by defining a database what I mean by constructing a database, what I mean by manipulating a database, what I mean by maintenance of the database, what I mean by sharing of a database. So these all things should be very clear, and for that you have them one by one. So first we will understand what means by defining our database. So this basically involves specifying the data types. I will write, it will specify, like in this step what we will do, we will specify the data type, we will specify the data type, we will specify the structure, we will define the constraints of the data, constraints of data. Okay, so basically we are defining that what kind of data will be stored, what will be the structure of that data, how the data will be taken together or interlinked to each other, defining a database. And constraints means some kind of conditions on the data. Now this particular description, whatever you are defining as in the database, this particular description is also stored in database. So basically, yes, now better. So basically what we mean that the description, like what is the data type, what is the structure, what is the constraint of the data, these all things, the description of this data, the description of this data is also stored in the database management system in the form of catalog. You have catalog, you have dictionary, you have metadata, you have informative data. So these all things are there. Now understand, when I say defining a database, here you get a lot of good concepts to understand, and these are also very important. Defining a database means, what we mean by defining, we have to specify the data type, the structure, the constraints of the data, and then whatever we do as a defining step, whatever we are trying to do, we are making the system more how you can say, we are defining, we are basically elaborating, describing the data. So all that description about the data or what the procedure we are doing, that is stored in the database also. So the data is stored in the database management system, plus the description about that data is also stored in the database management system in the form of either catalog, dictionary, metadata, or informative data. So you might have heard about the metadata. Metadata is data about data. Means if I say age is your data, then what type of data type is of age? So age is having an integer data type. So integer is the metadata about the age. So differently, you have catalogs to maintain the to hold the data description, you have dictionaries, you have metadata, and you have informative data also. Is this clear? Defining a database, is this clear? So that we can move to the next step. Yes, nice. Now, constructing a database. What is meant by constructing a database? So constructing is basically process of storing the data on some storage medium, and that will be controlled by the database management system. So basically what we mean here, we actually process the storing of the data on some storage medium. Basically storing data on storage systems, which is controlled by database management system. So basically constructing our database management system means we want to construct the data. So what we have to do, we have to load our database with the data, and that is called the storing of the data, and we have to do it on some storage system, and the entire entering of the data, like insertion of the data or constructing of the entire database, is controlled by the database management system. This we mean by constructing a database. Now I think it is copied again. So yeah, manipulating, I will delete this slide. Manipulating database. Now what we mean by manipulating of the database, it is basically querying the database, updating the database, or generating reports from the database. Generating reports. So basically, when I say I'm manipulating the database, I am either querying the database and changing some values in the database. I am either updating the database with some new value or trying to delete something, or else I am just generating reports. When I say I am only generating reports, I might be not changing the data, but I might be changing the look and feel of the data in order to get the visual information or different kinds of information as per my demand. So this is what we mean by the manipulation of the data. Now the next thing that the database management system supports us as a general purpose software system is sharing the database. So sharing the database means multiple user and applications are allowed to access the database, meaning multiple users or applications are allowed to use, or you can say access, database parallelly or simultaneously, you can say. So this is what I mean by sharing the database. For example, you all go to Amazon and you query for a particular product. So there are multiple users who are doing the same thing, maybe the same kind of product also they are looking, and you feel like you are only the one who is using the application. So basically this sharing in an isolated manner is also one of the things that is very important, and it is allowed and it has been done with the general purpose software system. Now, protecting the DB means how do we protect? This is related to security, and security is one of the major concern in every particular chapter which you will study, either database or networking or algorithm. You will, every time this is the concept which you can be getting in all the subjects, and which is very, very, very important. So basically, security of the database management, security of the database basically. So it helps in the protection against the software and hardware malfunctions. So basically here you have to protect your system against the software or hardware malfunctions and security protection against unauthorized access. So basically, whenever you are having a data, you should definitely try to incorporate security techniques in order to avoid any malfunctions from the software or the hardware. And also you have to protect your data from unauthorized access, and you have to look into the concepts of confidentiality, integrity, authorization, authentications, these all aspects from the perspective of the data protection. Now, the last one that this DBMS as a software supports is the maintenance of the database. So when we say maintain a database, basically it is like something which is incorporated for long years. You will make a database, and this database will be used for several years, like decades also it will be used. So you know that this is something which is going to remain in the system for a long period of time. So you need to maintain it, and to do that you have to take care of the evolving requirements, and you have to do the changes that are needed to be done on the technological front and other fronts. So basically, when I say maintenance of the database, why I need a maintenance, because these database which I am having are going to live long for years, and the data is very important, so it needs to be maintained, and it needs to be evolved as per the requirement. It needs to be evolved as per the required scenario, you can say, or requirement. And it needs to be changed over the period of time also. Change over time is also needed. You can write like this. So for example, if your transaction is there, for example, you have your statement from the bank. Suppose at the start of the month, you have, let's say, 10 lakhs in your account. Now, at the end of the month, you might have only 7 lakhs in your account. So the current scenario of account balance is 7 lakh. Initial was 10 lakh, but the data is changing from 10 lakhs to the 7 lakh. But you need to store all the things as the history of the data. In the similar manner, you can understand the data requirements will change. Sometimes due to software changes, you need to store them in a different format, and there will be different things which will come and go. So you have to maintain those changes over the period of time, and also you have to evolve your system as per the required scenario, so that interactions with the other components which are working all together in the database management system works properly. So these are the 6 things which the DBMS actually do with the database. So DBMS is a software. At the end, what is DBMS? DBMS is a software which is helping you to maintain or manage your database. And how it is helping? These are the ways in which it is helping. First of all, defining, then constructing, manipulating, sharing, protecting, and the maintenance. Is this clear to everyone? Is this clear? I take your silence as yes then. Yeah. Now, you have to understand a new thing. In many books, we will see, or in many like jargons also, or technical stuff, we will see that we have something called as database system, not database management system. So in the standard books, you will encounter this word database system. What database system means? Database plus database management system. Both of things are different. Database is a different thing. Database management system is a different thing. If you combine both of these together, you will get a database system. In many books, they refer as same terms, like database management system and database system. Both means same. But if you want to go in the technical definition, it is different. Database system involves the entire thing what you see in this particular image, and DBMS is only the part of it. You can see the middle part is the DBMS software. The above part is the database. Here these are the database, and entire system altogether, which is confined in one rectangle, is the database system. So how we actually go for this particular scenario is like, you have to understand how a typical database system works. So you are the user or the programmer who is interested to use the system, and first you will be having some application program or query programs like SQL or NoSQL. You will have some application program through which you will be interacting to the software of like database management system software. So you don't have the direct access to the database management software system. You will get it before, like there will be a kind of interface. You can take it as an interface between the user and the database management system. Once you query it, the data will be transferred to the database management system, and here they will be having subparts to the softwares. For example, software to process the queries, and then software to access the data. So first, whatever query you have provided from the interface, it will get evaluated or it will get processed. Processing of the query will happen, and then as per the query demand, the accessing of the database will happen. Accessing of the database will happen as per the query demand. Now, this particular thing will get interacted, like there will be again interfaces. It is not like it has direct kind of access to the low-lying databases. So basically there will be two kinds of databases which will be maintained. Stored databases means the where the data is stored, and stored database definition, where the definitions of the data, like the data about the data, like metadata, catalog, which we discussed, will get stored here. So if you are querying about something which requires data about data, not the data itself, you will have something called as stored database definition as the metadata or anything like that. The query will access this thing. So these are two separate things which are maintained separately, and if you want to access the data, it will get stored. You will have it from the stored databases. So this is basically what I mean when I say database management system plus database is equal to database system. Don't worry so much about it, but if you see somewhere database system and database management system both mentioned in the same paragraph have this kind of a boundary between these two things, if you only have the entire word as database management system in the entire book or in the entire paragraph or something like this, you can understand it as anomalous to the database system. So this is how you understand the database system altogether. Remember this one, how do we access it? So first, the interface will redirect you to the software will process it into major steps: processing of the query, then accessing the database as per the demand of the query, if it has to go to the metadata section or it has to go to the stored databases. Now, how we actually design a system? Is there anything that anyone is asking? No, right? Okay. Yeah. So designing of a new database or new application in an existing database. So whenever we will say database, either a database will be existing and we want to add a new application to the database, or there might be a scenario where we need to design the database from the scratch. So both of these steps, designing a new database or designing a new application in the existing database, requires some steps. And these are the steps which I have given you here: requirement specification and analysis, conceptual design, logical design, physical design. So basically, these are the things that you have to understand when you say that you want to design a new database. So you have to provide these four basic pillars. When you want to design a new application in the existing database, you again have to consider, before updating anything, these four parameters. Now, first one is requirement specification and analysis. Means, what is your requirement? It is as simple to the software engineering requirement specification step. What is your requirement? For what system, for what module, or what purpose, basically? what purpose you want to serve with the database, what kind of information you want to store, how you want to access it, all those things. Basically the things related to the metadata will also be here. And we discussed about designing a database, so whatever we discussed there, this is as similar to requirement specification and analysis. Like what will be the type, who will be the users of the systems, who will be the users of the system, for what like this if I say the purpose, will it be general purpose or for a specific purpose? Like for a specific purpose, let's say banking, airline system. For general purpose, there might be something which is related to some citizen offices or something like this, or Aadhaar, let's say, these things. So what is the purpose? Then the data, about the data which you are going to store, the relationship between the data, and how your schema will look like rough schema, not the entire thing, basically the foundation. So this will actually be the foundation of the designing of the entire system. If you do anything wrong here, everything will get translated after this step only. So this is the very first step where you will have to provide the inputs, and these inputs will be taken in the further steps. So if anything goes wrong in the previous step, then the next step will be a problem, or it will not serve what you thought in your mind and what is actually getting translated. So there will be a difference, and in order to avoid it, we have to spend a good amount of time, at least 30 to 40% of the entire life cycle development time of the database in the requirement specification. This is the most important step. Now the conceptual design. In conceptual design, you can just see that how you are going to make the different components linked together conceptually. You are not basically you are trying to be an architect here. You are trying to be an architect here, and you are trying to design something conceptually, that this is the conceptual model, and I want to get this conceptual model translated into the logical model. And when you will say logical model, basically ER diagrams and these different things will come, more peculiar things will happen. So conceptual design is kind of a bird eye view over the schema of the database. Logical design, it will be more going more in deep. For example, like ER diagrams, ERDs, and extended ER diagrams, advanced ER diagrams, these things will come into the scenario. So these are the logical designs as per which the data schema and everything will be related to each other. Then you have the physical design, means it is related to the hardwares. What kinds of hardwares we are going to use, and what is the physical capacity of the system, servers, or backups, recovery, all these things which are actually dealing with the hardware of any systems, they will be actually taken in the physical design pillar. So these are the four pillars which will remain same. So if somebody gives you a question that explain how you will design a new database, or how you will add a new application in the existing database, these are the steps that you have to take into the scenario: requirement specification and analysis, conceptual design, logical design, and the physical design. And remember, all these four should be independent. When I say independent, means if I change anything in the physical design, it should not hamper my logical design. If I change anything in the logical design, it should not hamper my conceptual design. So everything has to, it should not be interdependent. Inputs are taken definitely, but there has to be a kind of independence between these things. Otherwise, if one of the system component get changed, it will be a huge cost for other components to get evolved as per that particular change. So we try to keep it as minimum as we can. We might be having some changes if we do something in conceptual design or logical design, because they are related by logic. But anyhow, if there is a physical design which is getting changed, let's say you are changing the servers, you are changing the infrastructure of the database management system, it should not hamper the above three steps. So this is very, very, very important. There has to be a kind of degree of independence as well as interdependence in such a kind of frequency which does not affect the system badly. So this is about the designing of a new database or an application approach. Now, features of the database approach. So what are the features if I say if I have a database approach? Let's say there are two kinds of approaches basically. File of system approach, which basically traditional file management system. If you are using computer, you do it on Word or Excel or something like this. But if you are doing on any software which is having like database, traditional database, even traditional database, it will have some kind of features. So what all features or characteristics a database provides to you? So basically the very first thing is the self-describing nature of the database system. Means what? When I say self-describing nature, means the database management system, it's know about itself also by the means of catalog or this catalog will not be like it's this one, only this is spelling CATALOG. Now whatever data I am going to store in my database system, that is okay. I know what is the type, how it has been related. I know the data about the data also. So this is the feature of the database management system or database itself, that I know the nature of the data. This data itself is self-describing about itself. I will not be clueless if I am new to the system. If I want to know the system from the very architectural perspective, I will be able to know it because of the self-describing nature of the database system. Now, there is always an insulation between the program and the data. So because you have the data here, you have seen, and then there are set of programs which are used to access the data or modify the data or manipulate the data. But there is always a kind of insulation, means program and data will always have some kind of interfaces between them. And this is very important so that nothing like if I want to remove some kind of programs or some kind of data, it will not affect either any one of them. So insulation is also very good feature which actually gives the rise to data abstraction, and we are able to present the data which is only useful or needed for a particular user, and we hide remaining data. So data abstraction comes from step number 2, data insulation between the program and the data. Now it supports multiple view of the data, meaning let's say I have a database system of all the employees of the company, and I have every information of for the employees of that company in that database table, let's say. So HR will have a different kind of view, the employee itself will have a different kind of view to the data, and the administrative IT department will have different kind of view. So same data with multiple views is also possible. So you don't have to create separate data base system or file system for each different types of user to avoid any kind of like to make sure there is nothing called as piracy in the system or unauthorized access in the system. So you can avoid these all things by supporting multiple view of the same data. Then sharing of the data and multi-user transaction processing. So basically sharing of the data means you can access that same data simultaneously with different users with a degree of isolation, and also multi-user transaction processing, which is like OLTP, like online transaction processing systems. So basically multiple users can have the transaction system. They will update some shared data, they will update some non-shared data, and all those things are possible without any problem. And these makes the system robust and useful for the database approach. So these are the features of database approach. These particular points which we are discussing, they makes more sense when we talk in interviews, when we write a descriptive question which is based on these particular things. Like if I say, if I have a question, explain what is database, what are the things that we need to keep in mind while designing a database, what are the features of the databases approach, people find that all the things are same because they don't have the clarity between the independence or the boundary line between these topics. But these are different things, and once you start doing them, then you get to know how different they are from each other and how features are different from the way how they are being developed and also how they are being presented. It is all different. So these are the points which you should keep in your mind, should revise before the exam, so that if any kind of descriptive question comes where a small concept is asked, you can provide a good data, a tangible data, also meaningful data, to increase the word limit at least. And once you do it with these kinds of technical vocabulary, it increases the weight of your answer. So this is one of the very important things, and these are point based things. So you will read it today, you write some descriptive questions on this, and then you go and revise it before the exam. Now, what are the different actors in the scene? So this is kind of a play, and we have different actors in the scene, means different users or different players involved in the entire process. So how this entire picture is being shot? So different actors. Number one actor is DBA, which is called as database administrator. So basically, I have provided simple paragraphs for every particular type of user, but I will give you a brief about it. So basically, in database management system, you have a database, which is the primary source. Then you have DBMS, right? And the related softwares which are used to access the database. Now, how to administer these all things? What is this? How to administer these things? These are the responsibility of the database administrator. Database administrator is having the highest privilege over the database, and he is able to authorize access, grant. When I say authorize access, he can grant the access, he can revoke the access. He has the responsibility to make sure that coordination and monitoring of the software is in place. Also, if there is any change needed to be done at software level or hardware level, he has to get in touch with database designer or database architect in order to get it done. So basically, DBA is whole soul person who is keeping a bird eye view on every aspect of the database management system, and also it has to take care of the responsibilities such as security breaches, the response time of the system. And in large organization, this particular thing is not done by only one person. There are multiple persons and the staffs which support these particular functions. So DBA is one of the very huge responsibility. If you are working as an DBA, you will have to take different kinds of things in your mind: security, maintenance, responsibility of having the data in time, also making sure that the infrastructure is good in place. So this is the thing which lies with the database administrator. Now, database designer. So database designer is basically the other party which actually designs the database. By the name itself, it is clear. So here they are responsible for identifying the data that needs to be stored in the system, and how to store it, like what will be the structure to store it, and how you want to represent that stored data. So there will be data, how to store that data, and how it will actually look into the system. All these things, it has to be done by the database designer. And these are basically taken before the database is actually implemented or populated. I said you, when we were discussing the steps involved in creation of the database or adding new applications to the database, designing was done before, because once the designs are ready, then we will move ahead with the data insertion and constructing the database basically. So database designer do the defining of the database, and then everything which was related there with the requirements and everything what needs to be understand from the perspective of the communication in all those things, from the perspective of users also, it will be taken care by the database designer. Now, end users. So there are different kinds of end users, and they vary from the degree of how seriously they want to use the system, how aware they are about the system, and what is the purpose of them using the system. So the very first kind of end user is the casual end user. So they are like casual end users. They occasionally access the database, and they may need different information each time. For example, if you are visiting some websites occasionally, like let's say once in 2 months or once in a year, you are a casual end user for that particular website. Now, naive users. What are naive users? Their main job is basically to keep disturbing, or basically not disturbing, keep bothering the system. So basically they will keep querying the system, and they will keep updating the databases also. For example, if you understand the functionality of mini statement from the ATMs, or statement functionality, statement generation functionality in your net banking, if you are doing that particular thing, you are regularly doing it, and this is something which is constantly querying the system for the standard purposes. So if you say generate mini statement, so that is already been known to the system. System know that this is a standard query. So if you are only using the standard queries for your own purpose, then that is called as the naive user. So then you are a naive user. But the degree or the frequency of interaction with the system is more with the naive users as compared to the casual end users. Now, the next one is the sophisticated users. Sophisticated users are for specific purposes. For example, there are some softwares which only engineers will be using, scientists will be using, business analysts like Tableau, R, Excel. These are not used by everyone, right? So some softwares which will only be used by specific systems users, they will be called as sophisticated users. Then there are standalone users. They actually maintain personal databases, and basically they like you install them. There are some softwares for which you need to install them, and you can use them standalone without any networks or anything. Okay, so these are some of, like, if you want to have a software which will maintain your financial product listing or your finances, which will help you to manage your finances, your monthly savings, income, and all those things. So these are the users which are doing it for only one purpose, one kind of specific purpose, and they are not so complicated. They are usually like graphic based interfaces and menu based things. So that is something which you call as the standalone user. So these are the four major types of end users who are the actors on the scene, which you will get as the user's perspective. Like if I say how many types of users, so these are some few types of users. Okay, now what next? Then we will go and read about the architecture, 1-tier architecture, 2-tier architecture, and 3-tier architecture. But we will do it in the next session. So please do join from this link, and we will resume for the further section. Okay, so I think now we can resume, and it will not take much of the time, hardly 15 minutes. And then I have few questions which are based on today's session only, which you can try to write if you want to. So basically what you have to do, first get an idea whether those questions make sense to you, how to write them, are you having any idea after reading the class, and how good you are with the writing. So you have to make all the descriptive questions in one place altogether, so that you can revise before the exam, that are you having thoughts on that particular kind of questions to give a particular structure answer. So now DBMS architecture. So the next thing that we should be knowing is DBMS architecture, and the database store a lot of critical information to access the data quickly and securely. Hence, it is important to have a correct architecture for efficient data management. So basically, architecture is very important because it will come from your conceptual design. The architecture portion comes from your conceptual design. Remember, conceptual designing is the part which has been taken, which will take your architecture for the database management system, and it has to be well defined, it has to be well modularized, because all other things will be derived from your architecture only. So basically, DBMS architecture, we can have three types of architectures: 1-tier, 2-tier, and 3-tier architecture. So what is 1-tier, 2-tier, and 3-tier architecture? Let's understand. In 1-tier architecture, the database is directly available or accessible to the user, and the user can sit on the database management system and use it directly. For example, the client server and database are present on the same machine. So you have a same machine where your client is there, where your server is there, and your DB is also there. So all the things resides on the same machine, and you don't require any separate interfaces to access them. There is no kind of modularity. There is nothing called as the bifurcation of the things between the components, which is client server and the database. They're all present all together. So in one level only, you maintain the three things together. This is called as 1-tier architecture. In 2-tier architecture, it is similar to the client server model which you have in your networking. So in client server model, the application client, like the client which is actually going to query the system, directly communicates with the database at the server side. So basically, you have two parties in client server, one party is client and one party is server. So you directly can communicate to the server side of the database. And here, the application on the client side will establish a connection with the server side, and then you will be able to communicate. So basically, there is a kind of connection which you need to make before communicating. But in 1-tier, you don't require any such kind of thing. you will be able to do it right away. You don't require to set a server and client connection for the communication. You can do it directly. You can directly communicate to the server or the client. The communication between the client and server is direct. But here in 2-tier, there is something called as connection. You have to make the connection and then only it will be done. Now, the next thing, 3-tier architecture. What is 3-tier architecture? In 3-tier architecture, basically, there is another layer added between the client and server. So I have a figure for this also. We will see it in the next slide. Just understand what we mean by 3-tier architecture. So in 1-tier architecture, we have only one layer. In 2-tier, we have 2 layers, and in 3 tiers, we have one more layer between the client and the server. And here the client does not communicate directly with a connection to the server. Instead of it, it interacts with the application server, which further communicates to the database system, and then query processing and transaction management takes place. For example, the image that I showed you while understanding the DB system. Here you can see there is an application-based system which actually help the user to interact with the database software, and then that database software interact with the data which is being stored on the database systems. So similar thing is this, and 3-tier architecture is the one that is being used prominently nowadays. Somewhere there is also 2-tier architecture depending upon the case to case. If we don't want the system to be more complex, we can make it 2-tier. And if the information is residing in the system is also not so private or confidential, then it is okay to have 2-tier architecture because it will reduce the cost. But if you are going for something which requires a more secure system, more modularized system, then you have to go with the 3-tier architecture. So there is an extra layer between the client and the server. So here you can see in the 2-tier architecture, you have client and you have server. User is using the application and it can directly communicate, right? And in the 3-tier architecture, you have an application server on the server side. So the layer which has been added in the architecture is actually added on the server side. So client is not aware to whom he is interacting. It actually seems like they are interacting directly to the server, but no, there is a kind of proxy between it, and that is the application server. So application server will actually be acting as an interface between the DBMS and the client, and then the client will access the application server, which will further provide the access to the database. So this is how the 3-tier architecture looks. 3-tier architecture is the best architecture, but if you don't have a complex system and the data which is being stored on the system is not confidential, it is like of a general only read-only thing, and if anybody can access it, why to increase the complexity of the system? It will be like 2-tier architecture. 2-tier architecture will be faster as compared to 3-tier architecture, definitely, because in 3-tier architecture you have an extra layer which will increase, at least even if it increases 1 nanosecond, it increase some time in the response time, because client to application server, then to server, that is the database management system. Then once you get the response, this is the request part. Once you get the response will come from the database management system to the application server, and then from the application server it will go to the application which the user can see. So if I have to compare 2-tier versus 3-tier, 2-tier less cost, 3-tier more cost, 2-tier more less secure, 3-tier more secure, and 2-tier is slower. Sorry, 2-tier is faster and 3-tier is slower. It is not like much of the slower thing, but yes, it is little slower. Now, potential descriptive questions which you can write after this class is like these 6 questions. Let's just take a look on the questions. First question is, define the following terms: data, database, database management system, database system, database catalog, program data independence, user view, DBA, end user, chain transactions, deductive database system, persistent object, metadata, and transaction processing system. So you can skip this deductive database system. You can avoid this one for now, and also persistent object you can avoid. But other than this, will you be able to write if this kind of question come in NABARD for, let's say, 15 marker? Is this okay? If this kind of things comes that you are having, let's say, for 15 marker, these are the subparts. For each subpart, you will get, let's say, 2 marks or 3 marks. So you will be able to write, right? Yeah. So this is the thing which you will understand from this particular class. The next question is, what are the 4 main types of actions involved in the database? Briefly discuss them. So what were the 4 major actions involved in the database? Do you remember this? 4 main types of actions involved in the database. We discussed it. All the questions we discussed today. So just tell me, if I ask you, what are the 4 main types of actions involved in the database? If you see this slide, 4 main actions. You can see this thing. I defined you 6 main actions for the database, right? Defining, constructing, manipulating, sharing, protecting, maintenance. So these will be the 4 main actions which will be there, which are actually involved with the database. Now discuss the main features of the database approach and how it differs from traditional file system. So what is the characteristics of the database approach? Again, the same thing with the different questions. These are the features of the database approaches and how they differ from traditional. Whatever is positive from this, that will turn negative for the traditional system, and that is how you have to write the answer. Now, next question. Are these 3 questions clear? Discuss the main characteristics of the database approach and how it differs from traditional system. I think so, yes. What are the responsibilities of DBA and Database Designer? I think this is also very much clear. Then what are the different types of database end users? We discussed 4 types of database end user. And what are the different activities? I have given you only 2-3 lines, but I have explained it in detail. So you can also suffice your answer with some real-time examples. You can elaborate about the example that, see, this is the user, how the system, how they are interacting with the system, and due to this, they are of this type of user, and this is the impact on the database, on the perspective, how they are using it. Then discuss the capabilities that should be provided by a database management system. Again, this question and the question number 2 are somehow similar only. So, but the language can be different. So if this question comes, discuss the capabilities that should be provided by a DBMS. So what are features, things, how, and whatever are the offerings. Like if you get a product, they will say, we will provide you this, we will provide you that. So whatever is the capability of the database management system, that you have to write, whatever you know from the perspective of security, protection, maintainability, designing, defining, accessibility, whatever you know, you have to define it in question number 6. So these questions are very normal questions, and just make these questions somewhere, take a repository kind of thing for these kinds of questions, so that what they will do, once you are going to appear for the exam, just 1 week before the exam, you start revising the descriptive questions. So let's say before the 1 week of the exam, you will see, let me see the descriptive question for database management system. That time, let's say you have 60 database questions, potential questions which can be asked. So you will just read the question, and if in your mind you are getting an answer, you're getting a response, that confidence is there that I can write this answer, then you are good. Otherwise, what you will do, leave 2-3 lines after every question. Leave 2-3 lines and make keywords there, or small images like flow charts or something like that. And before the exam, just revise it and go. You don't need to read a lot of steps. Just make small mind maps or small flow charts, so that before the exam, you can read everything just with 15 to 20 papers. Okay, so this is how you have to do it, and then it will be all good. If you have a lot of time, you can write these answers. If you don't have, just make the copy of the questions and leave some space, or like if this is the first page, in the next page, if you are taking a print, next page keep it blank, and make notes on the next page, so that whenever you see that question, you can't directly see the answer. And if you want to know some answer to it, like you are not able to recall everything, you can see back of the paper where you have made short flow chart or something like this, and it will be good for revision. Okay, so was that all clear?